All right, this is Mr. Muscarella speaking to all the mathletes out there. And that's right, we're going to take a look at graphing the tangent function now, and we're going to formalize this a little bit more. So if you haven't seen the previous video on the introduction to looking at it graphically, be sure you check that out. Now, when we looked at it graphically, remember, we were right here, and we had all this lovely function going on here. So here's our tangent function graphed using Desmos. So we're going to put this together without the Desmos and taking a look at different things with it. So when we look at our notes here, so let's kind of go back to a couple of things on this. So tangent, remember, is sine divided by cosine or y over x. Let's take a look at the unit circle, shall we? So when we formalize that right here, we know the y divided by the x coordinates. So right here and right here, at both of those on the x-axis, the coordinates are 1, 0 and negative 1, 0. And some of you might have this totally memorized, but if you do y divided by x, in either one of those cases, you're going to get a value of 0. So the tangent is going to be 0 at 0 degrees or at pi. So at 0 degrees and pi, the tangent is going to be 0. So we're going to fill that out. But notice also, like if we went around in a negative direction, we still end up at the same spot, bro. So that would also have a value of 0. So at all these spaces and places at negative pi, 0, and pi, we're going to have zeros. All right, then let's take a look at those two other spots on the coordinate axes. Up here at 90 degrees or down here at negative 90 degrees or negative pi over 2. The coordinates here, right, are 0, 1 and 0, negative 1. So if we did y divided by x, negative 1 divided by 0 or 1 divided by 0, that's where, remember, we get those tangent values of undefined. So the tangent is undefined at pi over 2. But if we went in a negative direction, it would be negative pi over 2. And all the odd multiples of pi over 2. And we kind of covered that a little bit last video. So at pi over 2, it's undefined. And at negative pi over 2, tangent is undefined. Now, what makes this function a little bit different is that we determined before that the period was 4. So when we go to graph this, right, our units are going to, we always take the period, and we divide it by 4 or multiply it by 1/4, whichever is easier for you to think about, because there are 4 quadrants. That's why we do that. So our units are going to be pi over 4. So we're going to label our axes. So here, oops, where'd that go? Come on back. So our units are going to be pi over 4. So 1 pi over 4 is there. Now 2 pi's over 4, we're going to reduce that down to pi over 2. Now we've got our 3 pi's over 2. Over 4, sorry, and then we'd have 4 pi's over 4, which is just pi, and then 5 pi's over 4. So that's the right side of the coordinate axes that we have. Then going to the left, we'd have negative pi over 4, negative pi over 2, and negative 3 pi over 4, and of course, negative pi would be our last point on this function. All right, yeah, that's correct. So those are the pieces that we have labeling our coordinate axes. Now, that's part of it right there, but then we have these other values. And again, we're going to kind of go to the unit circle here. So when I know my x and y coordinate both up here are in quadrant 1, both of those at pi over 4, they're going to be root 2 over 2. So both the x and the y are root 2 over 2. And when I divide that by y divided by x, or sine divided by cosine, I get a value of 1. So at pi over 4, I have a value of 1. Now, if I went in the negative direction, right, down this way, the only thing that would change would be my y coordinate would be negative. So I'd have negative pi over 2 divided by pi over 2. So at negative pi over 4, that value would be negative 1. So those are going to be those two spots right there. Now we know from ASTC, so again, we're kind of pulling a lot of stuff in here together. So ASTC, so all students take calculus in quadrant number 3, which I can get to positively or negatively. So if I went in a negative direction to that spot, which is in quadrant 3. So normally going around the unit circle, that would be at 5 pi's over 4. But if I went in a negative direction, that'd be negative 3 pi over 4. So tangent would be positive there, and that would have a value of positive 1, because both your x and y's are negative root 2's over 2. So that has a value of 1. And then at 3 pi over 4, so up here in quadrant number 2, both the x and y are opposite sides. Even though they're root 2 over 2, one of them, the x coordinate is negative, so we'd have a value of negative 1. So when we go to graph this First thing we'll do, of course, is graph our little asymptotes. So pi over 2, we'll go ahead and graph that. And a negative pi over 2, we'll graph that. And that'll be one of the things I look for in your graphs, is to make sure that you have the asymptotes correctly graphed. Then we're going to just kind of start from the left side and continue on. So notice the pattern here. So I'm going to put 0 right here on that axis. So we're going to do that. But then I'm going to make these go by 1 just to give us a little bit more space. So at negative 3 pi over 4, we're at 1. So we want to have that curve go up. Now it's going to continue to go down. So make sure you draw your arrows on the end of that, because that's what the function does. It goes up forever and down forever. Now, in the middle, so our next spot, we had negative pi over 2, and then negative 1 is where we're at for negative pi over 4, so we'd be right here, and then 0, and then at pi over 4, we're at 1. So that would be the parts of our graph going right there. Don't forget the arrows. And then at 3 pi over 4, so you can start to see the pattern starting to repeat. So at 3 pi over 4, we'd be at negative 1. At pi, we'd be at 0. And at 5 pi over 4, we'd be at 1. And so then we draw our graph. And so make sure it's curved. You know, we've got a little bit of bend in our curve. But when we look for this, we'll be looking for the asymptotes. We'll also be looking for this low point right here. You know, and then we'll be looking for this axis value at 0, and then we'll be looking for this higher point up here where on the parent function of tangent you have a value of 1. So those would be the 3 values that we look for in the curve. The other stuff in between, where it's root 3 over 3 or, you know, square root of 3, like I don't care about that. Like, as long as you can graph those values and sketch those, you good. Now let's talk about domain and range. Now the range, because this thing goes down and up forever and ever, so that range, of course, will be negative infinity to infinity. Now the domain, remember the domain is like, we don't have all the numbers because it's like pi over 2, negative pi over 2, and we'll describe this using our vertical asymptotes. So remember the vertical asymptotes, they were at odd multiples. So let's write that down, odd multiples. Zoom in here, all right, here we go. Odd multiples of pi over 2. And if you need to, so that you remember, you can write like negative 7 pi over 2, negative 5 pi over 2, negative 3 pi. Like, you can write that pattern so that you remember it, and then positive pi over 2, 3 pi over 2, and so on. So you can have that pattern there if that helps you remember that. And this is, again, for the parent function. Now, let's see. So that was our vertical asymptotes. So the domain, I can't be those multiples of pi over 2. And the domain, all those asymptotes are where cosine was 0. So the domain is going to be all real. So we can abbreviate that with that cool math symbol. So the domain is going to be all reals except where cosine is 0. So the domain is going to be all reals except anywhere cosine is 0. And why is it where cosine equals 0? Because remember, we've got sine over cosine is the trig ratio for the tangent function. Now the period, we determined that before, so the distance between asymptotes is pi. And then the symmetry, so let's talk about that. We're going to go back to polynomials here for a second. So I want you to think about odd and even degree rational functions. So in that, we had a couple different ways that our function could go. So say we had the, ooh, that's gross. We're not going to do that. We're going to do this version. So say we had this vertical asymptote. Now our function, both ends could go up as you approach the function, or potentially you had a function where both ends of your graph went down. And if that was the case for a vertical asymptote, and I'm just going to make up a number here, say you have like x equals negative 2, then that means at a factor, as a factor, that would be x plus 2. So in the denominator, you would have x plus 2 squared. Now that doesn't matter if both ends go up or down. That would be an even degree function. But sometimes we get functions where you've got your vertical asymptote, one edge will go up, the other edge will go down, or vice versa, where you might have the function and one edge goes down first and the other side it goes up. Either one of those, when you have your vertical asymptote that way, you have an odd function. So when we take a look at our picture here for tangent, notice as you approach the asymptote from both the left side in the right side. They go in opposite directions. So that means this is going to have odd symmetry. And we could also analyze that from a table of values, because if we plug in, so we're going to take a look at two values, right, on the unit circle. We're going to take a look at pi over 4. That has a value of 1. That was our input. Now, if we plug in negative pi over 4, notice the y value is different. So you could also analyze it that way by saying, you know, odd functions, when you input x, you get a value. When you put input negative x, it should kick out the opposite sign. So just a little refresher there, f of negative x equals negative f of x. You know, that would mean that we'd have an odd function. So that's kind of what's going on there. We plug in pi over 4, we get 1, and we plug in negative pi over 4, and we end up with the opposite y value. So that's just a quick little refresher on that. So that's tangent. Cotangent is going to be very similar, except we'll have a little bit of shift. So that's it for this video. Thank you all for watching. Come on back and watch cotangent, and we'll catch up with you later on. Peace out.